Today, my presentation is going to be on the cryptocurrency Ethereum, but I'll be focusing on how it operates and how, in its application, it can revolutionize various industries. To provide some background on Ethereum, it's currently the second largest cryptocurrency, and as of yesterday, April 22nd, 2018, it had a market cap of just over $61.5 billion. It was invented in 2013 by 19-year-old Vitalik Buterin, who had a dream of adopting Bitcoin technology to allow developers to define their own use cases for the blockchain outside of peer-to-peer fund transfer. 2 years later, in 2015, a group of developers who joined Buterin were able to release their network, and the community of developers has since grown tremendously. So, what does Ethereum even do? Like Bitcoin, Ethereum is a decentralized public ledger, but unlike Bitcoin, it focuses on the decentralization of applications, also called dApps. Ethereum is a world computer. Anyone can write programs to it or call programs from it. It technically has only one processor, as in one process is being verified by the blockchain at one time, but has as much memory as is needed. Developing on the blockchain previously required lots of background in cryptography and advanced computer science, but Ethereum lowers that barrier for entry with a JavaScript-like language called Solidity. With Solidity, people can create their own payment protocols that are secured by the blockchain, or use the blockchain as the backend verification and storage network to support applications. Another really interesting aspect of Ethereum is its proposed use in social contracts. A strict set of rules can be set about who gets to vote in a specific decision making, and those approved can easily cast their vote without worry of hacking or dishonesty. This attribute will have really interesting implications for the future of crowdfunding or even political elections. So why build on the Ethereum network instead of the internet? Like we learned about last semester when studying cryptography, Ethereum utilizes public-private key cryptography. This means the transaction's sender can be verified with a message that, when decrypted with the public key, can be known to have only come from one person, and with the same process can be verified to have not been tampered with. Also, the network is resistant to direct denial of service attacks because the decentralization eliminates the opportunity for a bad actor to overwhelm one single server. However, in recent months, a decentralized application called CryptoKitties, with unexpected popularity, clogged up the network and caused extended wait times. This was a sort of wake-up call to Ethereum idealists that the network isn't quite ready to take over the regular internet, but also displayed people's eagerness to adopt it. Additionally, Ethereum lets you utilize the memory of the distributed network, so there is no necessity of purchasing and maintaining databases. Basically, Ethereum lets you define the constraints of an agreement that you would like to enforce, and you can do so without these barriers that the regular internet has to overcome. The Ethereum virtual machine is what makes all this possible. It's the runtime environment that allows the user to write and deploy smart contracts to the network and is the major innovation of the Ethereum project. Other languages do exist, but this is the one that is being frequently updated and is the most powerful for the purpose of building smart contracts. The language is frequently compared to JavaScript and has many fundamental concepts that are familiar to programmers, including variables, functions, classes, arithmetic operations, string manipulation, inheritance, and more. Other cryptocurrencies had only aimed to develop peer-to-peer fund transfer systems, and with Solidity, you can create a customized fund transfer as well as other specifications to satisfy a need. An interesting attribute of Solidity is that there has not been much time for in-depth development, so anyone interested could pick it up and, in experimenting with Solidity programming, might come up with something really cool and potentially brand new. So now I'll move on into some examples of what a smart contract might look like. This smart contract is the Ethereum website's recommendation for a first introduction to smart contracts. The mortal declaration with the function kill lets the owner kill the contract if they wanted to. This is important because without that function, any funds sent to this contract would not be recoverable, because smart contracts are immutable once they are published. It's also good practice to terminate your contracts once you do not need them, so that they don't waste space on the blockchain. You'll see that in the greeter declaration, it says contract greeter is mortal. This displays that Solidity has the capabilities of inheritance similar to the way Java does. The greeter contract is simple. A greeting of type string is declared, and once the contract is compiled, the creator will define what that greeting will be. The first method is a constructor method that is only deployed when the contract is called. This creates an instance of the contract. The greet function is the equivalent of a main function. Its only function is to return the defined greeting whenever it's called. To get a little bit more complex than a greeter contract, this contract creates a user's own new token. Admittedly, this is the bare minimum for a coin contract, but it does work. After initializing the contract, a public variable called balance of type mapping is created. This creates a hash map that organizes the address of users possessing this coin mapped to the amount of coin that they own. The next function defines an amount of initial supply. Depending on the function of a coin, the creator will have to decide if there should be a large amount available or a small amount. The creator is then given all of the tokens. The transfer function is simple. The two values passed into it are the receiver's address and the amount that will be transferred. It first checks that the sender's balance is sufficient to make the transaction at hand and checks that overflow is not messing up the transaction calculation. Next, it subtracts the given amount from the sender and adds that value to the balance of the receiver. Both of the greeter and this coin are severe simplifications of the capabilities that Solidity has, but make it clear how useful its applications are. From here, one can develop stricter constraints and implement a complex payment protocol without trusting the honesty and reliability of a single company or server. With the ability to create coins comes the ERC20 standard. Any token built on the Ethereum blockchain has to comply by the ERC20 defined constraints. This means it must implement certain functions to be approved for operation on the blockchain. Having a standard like this ensures that the developer will not be missing any critical functions and that the user will not be manipulated by a token that does not operate the way it should. In an article from medium.org published in January, Ethereum's share of the token market has gone up from 73% to 91% in 6 months. It is important to recognize the distinction between tokens and cryptocurrencies, though. Cryptocurrencies operate on their own blockchain, and tokens are based on another blockchain like Ethereum. From this statistic, it is clear that Ethereum is establishing itself as the primary platform to build other tokens. In late 2017, Fizzy was invented by the travel insurance agency AXA. This is one of the first major acknowledgments of the Ethereum blockchain by a company. Not only are they acknowledging the blockchain, but trusting it to serve in place of their insurance policy that usually involves person-to-person mediation. The smart contract is built, like the examples, to be triggered when a certain event happens, in this case a delayed flight, and instantly pay the flyer. Besides for this innovative use case, I find it extremely interesting to see an advertisement that looks like it could be a mainstream commercial, but is promoting an Ethereum-based technology.
You don't like to be delayed, neither do we. But when it happens, there is nothing you can do except hope for some assistance from your airline. You have travel insurance? Fine, but are you covered for plane delay? Whatever the cause of the delay? Not so sure. Even when you are eligible for a compensation, it can be a bit painful to get it. At Fizzy, we transform your hassle into financial benefit. Purchase Fizzy at fizzy.axa and get compensated instantly. No need to ask for it, no paperwork, no wasted time. Fizzy is a next-generation parametric insurer. Fizzy is transparent. The amount of the compensation is displayed to you before you buy and stored in a blockchain. Fizzy cannot change terms after your purchase. Fizzy is easy. You don't need to ask for compensation. If your plane is late by more than 2 hours, public databases of plane status information will automatically trigger your compensation. Fizzy is fast. You are notified of your compensation minutes after your plane lands. Fizzy is sure. Your insurance works in 100% of cases, whatever the cause of delay. Fizzy. You will learn to love delay.
Supply chain is one aspect of business that can benefit from how reliable and constant smart contracts truly are. Every step of the way, from the factory to the store, goods need to be kept track of. Not only does their location need to be known, but their temperature, weight, and quantities need to be kept track of by the company trying to make sure no third party is disrupting their supply chain. In the graphic, we can see that it is clearly much easier to take care of all these complications via a smart contract rather than several other documentations. Using the blockchain for financial data recording can lower the chance of error in bookkeeping. By automatically keeping track of every purchase, payment, and transaction in an immutable public ledger, the company commits to a simple and transparent public record. This would provide ease for companies trying to keep all of their records straight and would instill confidence in the public of honesty from corporations. There are plenty of other applications for blockchain technology to make various aspects of industries more efficient. Specifically, Ethereum smart contract technology will become increasingly more prevalent as advancements and developments are made. The community of developers is rapidly growing, and soon we will see it become a widely accepted standard tool.